Now that we know a little bit about activities and intents, let's look at the activity life cycle from the perspective of the Big Nerd Ranch Guide. This material comes from Chapter 3. The Big Nerd Ranch Guide outlines 4 main states that an activity can be in: non-existent, stopped, paused, and resumed. The easiest states to understand are the non-existent state and the resume state. The non-existent state corresponds to an activity that is not even loaded into memory. And the resume state corresponds to the activity that is currently running in the foreground of your mobile device. An activity that is paused is one that may be partially visible on the screen, but is not in the foreground. For example, if you're reading your email on your phone and you get an incoming call, your email application will pause until you decide what to do about the phone call. You may see the application running in the background, but until you answer or decline the phone call, you will not be able to interact with it. If you do answer the phone call, the email application will stop. If you decline the call, the email application will resume. An activity that is stopped is no longer visible on your phone, but is still in memory. If you're running an application and you hit the home button, the application will no longer be visible because you now see the home screen, but it will still reside in memory. Activities include lifecycle callback methods that are called when an activity transitions from one state to another. For example, when an activity is going from the non-existent state to the stopped state, it is being created, and the onCreate method is called. When an activity is going from the resumed state to the paused state, the onPause method is called. When you write your activity class, you can override these callback methods so that your own code gets executed when a particular state transition is made. The 6 primary callback methods in the activity lifecycle are shown here: onCreate, onStart, and onResume for starting up, and onPause, onStop, and onDestroyed for when an application is terminated. Note that when onCreate is called, onStart will also be called, and when onStart is called, onResume will be called. What this means is that you can't start or restart an activity halfway. If you start or restart an activity, it becomes the activity that is running in the foreground. The entire lifetime of an activity starts when it is launched and stops when it is destroyed. The visual lifetime of an activity starts when it is launched and stops when it is stopped. Remember, a stopped activity can still be in memory. The foreground lifetime of an activity stops when it is paused. This chart shows the distinction between the various states of an activity. If the activity is not even in memory, then it is non-existent. If an activity is in memory but is not even partially visible to the user, then it is stopped. If an activity is visible to the user but it's not in the foreground, in other words, the user cannot interact with it, then it is paused. And finally, if the activity is running in the foreground, then it's resumed. Let's look at the GeoQuiz application to illustrate some of the different state transitions an activity can make. The simple GeoQuiz application shown here only has one activity. The Big Nerd Ranch Guide contains excellent instructions on how to print out and read log messages using Android Studio. It shows you how to add a log message to each lifecycle callback method so that you determine what methods were called in what situations. This slide will take you through those calls for a few different situations, but the best way to see it work is to implement it yourself. The image here shows what happens when you hit Run for an application in Android Studio. Once you choose a virtual device, the device is created and the Android OS boots up. If you watch closely while this is happening, you will see the home screen appear for just a split second. It's only there for a moment, then the application that you are running launches. When the application launches, 3 callback methods are called: onCreate, onStart, and onResume. We're going to look at what happens when you select each of the 3 buttons at the bottom of the Android device. These buttons are the back button, sometimes represented by a triangle pointing left, the home button, usually represented by a circle, and the overview button, sometimes represented by a square. Hitting the back button not only stops the application, but it removes it from memory. Therefore, when you hit the back button after launching the GeoQuiz application, the onPause, onStop, and onDestroy callback methods are called. Let's look at what happens when we hit the Overview button after we hit the back button. The Overview button shows the most recent apps that were used. As we can see here, an app does not have to reside in memory to be a recent app. In fact, the recent screen will not indicate which of the apps shown, if any, is still in memory. In our case, we know that GeoQuiz is no longer in memory because onDestroy was called, but it still appears on the Recents screen when we hit the Overview button. Notice that no callback methods were called when the Overview button was pressed. That means that the app is still in the destroyed state, or the non-existent state, as the Big Nerd Ranch Guide would say. From the Recents screen, let's look at what happens if you do one of 2 things. First, if you hit the X on the image of the GeoQuiz application, it will disappear from the Recents screen. When the Recents screen is empty, Android takes you back to the home screen. Notice that when this happens, no callback methods are invoked. That is because the GeoQuiz application is already destroyed. Another thing that can happen is that we touch the image of the quiz and the application starts up. Since the application is currently destroyed, it must be created, started, and resumed before it becomes the foreground application. Now let's look at another possibility. Let's look at what happens when the GeoQuiz application is running and the Home button is pressed. When the Home button is pressed, the application is stopped, but it remains in memory, so it is not destroyed. Therefore, the callback methods invoked when the Home button is pressed on a running application are onPause and onStop, in that order. OnDestroy is not invoked. Now if we press the Overview button, the GeoQuiz application appears on the Recents screen. Since no callback methods were invoked, we know that GeoQuiz is stopped but not destroyed, so it still resides in memory, despite the fact that this Recents screen looks exactly like the Recents screen we saw when GeoQuiz had been destroyed. Again, there's no indication on this screen about whether a recent application is still in memory or not. Now we'll look at the same 2 possibilities we looked at before for the GeoQuiz application on this recent screen. First, we can delete the application. When we delete it this time, the onDestroy method is invoked. It was not invoked last time because it was already destroyed. Similarly, When we launch the application, we do not need to create the application as we did last time, because the application is already created. It is still in memory. Finally, let's look at what happens when we hit the Overview button from the running GeoQuiz application. This is similar to hitting the Home button. The GeoQuiz application is stopped but not destroyed. It remains in memory. And because it remains in memory, we see something similar to what we just saw. When we delete it, the onDestroy method is called. When we bring it to the foreground, the onStart and onResume methods are called.